Hi, hope you're well. We want to solve Singapore Mathematical Olympiad problems of junior section. Also, I will release senior section and open section. Now I get the problems. If for senior also and open section, if you had any question about the solution, feel free to send message to my WhatsApp number in the description and comments. Okay, so let's solve these problems. 30, 25 junior, it's so much easy. The problems junior open sections are hard. And also I will release like previous years 2021, 2020 and 2019 also for previous one. Also I release round 2 solutions of junior, senior and open section. And if you had for senior open part 1, if you had also saw this video and had question, as I said, feel free to send message to my WhatsApp number in the description and comments. Okay, so let's solve. It says which of the 5 numbers this is the largest. So when you want to solve these problems, it's good to, for example, check 2 of them. For example, let's check which of them. Okay, these are small numbers. 3 squared is 900. It is 900. Let me write it. 900. This one is 1000. 5 to the 4 is 625. It is 2 to the power of 10. It's 1024. And 3 to the power of 6 is 729. So let's see which is the largest. So the answer is D. Okay, problem number 2. Adele has a fruit basket containing 1 apple, 2 bananas. Okay, 1 apple, 2 bananas, and 3 oranges. It is for Adele. Betty has a fruit basket containing 2 apples and 3 oranges. Assuming that Adele and Betty each randomly picked a fruit from her own basket, what is the probability that together they picked an apple and an orange? Okay, here we should consider 2 cases. Let me write with flag. Adele select, it says what? 1 apple, 1 orange. So apple, orange, and orange, apple. So the probability here is 1 over 1, 2, 3, 4, 5, 6. 1 over 6 for Adele, and for Betty, orange 3, orange over 5. And here, orange 3 over 6. And for Betty, apple 2 over 5. It will be 3 over 30. It is 6 over 30. If we add these 2 things, it will be 9 over 30. And if we simplify, it will be 3 over 10. So the answer is problem number 3. The following diagram shows a system of balances hanging from the ceiling with 3 types of weights. The balances tip down to the heavier side. If we use square less than triangle to represent square is lighter than triangle, which of the following is true? Okay, here if you pay attention, square is heavier than triangle, and if you consider this part and this part, it is heavier. So we can say 2 triangle plus square is heavier than square plus square, which is 2 square plus a circle. Now, we can say triangle is less than, here, if we simplify, let's simplify it first. Subtract the square from both sides. So, here we can say what? 2 triangle is less than 2 square. And if we take subtract square from both sides, we understand that square is greater than circle. Now, here also you can say square is greater than triangle. So you can write triangle plus circle. And if you consider this and this and subtract triangle from both sides, then triangle is greater than circle. So we can say square is greater than triangle, triangle greater than circle. And we have this, so that's fine. So the answer is B. Problem number 4. A shop sells 2 types of buns with either cream or jam filling, which is indistinguishable until someone bites into the buns. 4 mathematicians visited the shop and ordered, not necessarily in that sequence, 3 cream bonds. The next one, 2 cream bonds and 1 jam bond. The third one, 1 cream and 2 jam bonds and 3 jam bonds. Each knew precisely which the others had ordered. So this one is important. Let me underline the things that are important. Each knew precisely what the others had ordered. Unfortunately, the shop owner mixed up the orders and gave each mathematician the wrong order. It is also important. The mathematicians started eating, all still unaware of the mix up, until the shop owner ran over to inform them of the mistake. Mathematician A said, "What? I ate 2 buns and both had cream filling. So if my order was wrong, I know what type my third bun is." Okay. Mathematician B said, "What?" Let me draw on the line with green. "I only ate the bun and it had cream filling based on what A said, and since I remember A's order, I know what type my other 2 bonds are." Finally, mathematician C said, "I have not started eating, but I must have received 3 jam bonds. Which of the following statement about mathematician D is correct?" So here we have what? If I write all the orders, I have 3 creams, 2 cream, 1J, 1 cream, 2J, and 3J. These 3 things. Okay, the problem says mathematician A said, "I ate 2 buns and both had cream filling." So he received 3C, or A received 2C, 1J, and he says what? If my order was wrong, it means what? It means that in his order he had 2 cream. Then I know now what type my third bun is. So in his order he had 2 cream. So in this case, the only possible case, 2 cream, 1J, there shouldn't be equal because all the orders are right. In this case, 3C. Now, let's consider B in both cases, order and what received. Mathematician B said, "I only ate 1 bun and it had cream filling based on what A said, and since I remember A's order, I now know what type my other 2 buns are." Okay, B knows the thing he receives is different from this, also different from this. He knows what A get from the things he said because he knows his order. The problem says, and it is not equal to this receive. So it is not equal to this and not equal to this. So for R, because he ate 1 cream, it can be not 3 cream, 2 cream, 1J, and 1 cream, 2J. He says he understands. Why? Because it is not equal to his order. This is not equal this order 2C1J, so he can remove, it cannot be 2C1J to remove this. One of them should be rejected, so we understand. So in this case, 1C2J he ordered, and so it cannot be this, so you understand that he received 2 cream, 1 jam. In this case, similarly, we say, okay, for received, if we want to consider, it is not equal to, let me write like this, it is not equal to this, to the order, not equal to this. So here, not 2C, 1J, it is impossible, so 3C or 1C, 2J. One of them should be rejector. It cannot be equal to 3C, so 3C cannot be rejected, 1C, 2J can be rejected. So here it is not equal to this. We found B. Now B in both cases can find what he got or received. Now C. OR. I've not started eating, but I must have received 3 jam bonds. So he knows it is 3J he received in both cases. 3J. And we know this order is not equal to this one. Let me write with red. Is not equal to this, is not equal to this order because orders are different, is not equal to this order. So 3J 1c 2j, 2c 1j. So what is left here? 3c. And for this one, not equal to this, similarly, not equal to the order here, and not equal to the order here. So 3c, 2c, 1j, so 3j, 1c, 2j. Sorry, here 1c, 2j we should say 2c, 1j. Okay, 2c, 1j and 3c. So let's consider now the last one, D, order what received. In this case, order 3c, 1c, 2j, 2c, 1j. So what is left? 3j, and it says what? Okay, mathematician D, what he says. Okay, for R, 3j, 2c, 1j, 3c. So it will be what? None of them. So 3c, 3j, 2c, 1j, 1c, 2j. And for this case, it will be what? 2c, 1j, 1c, 2j, 3c. So 3j, the order, what he received, 3j, 3c, 2c, 1j, 1c, 2j. So in both cases, D have this property. So let's check the choices. Let me copy. Okay, D ordered 3 jams, so it is wrong. D ordered 1 cream, D ordered 3 cream, wrong. D ordered 3 jam, but received 3 cream buns. No, received 1 cream, 2 jam. So it is wrong also, so the answer is E. Okay, problem number 5. If n can take the value of any positive integer, how many distinct value can the expression this take? Okay, so it is A. Now n is any positive integer. Okay, so for finding, because we have also choice infinitely many, so consider if n, for example, is a large positive number. If n is a large positive number, then a will be near n over 4 minus n over 7 minus n over 14 minus n over 28. It's somehow intuitive thinking. 28, 7n, if you use common denominator, 4n minus 2n minus n, it will be 0, around 0 for large n. So, and we know a is integer. A is integer because any of them are integer. So we can say what? We can say, okay, probably intuitive thinking. The answer is A, B, C, D. It cannot be. So let's see. A is maximum what? Maximum of A, and minimum of A is what? So because I want to find maximum and minimum for each of them, I should find maximum and minimum. Then, for example, if I want to maximize A, I should, because it has negative, I should maximize for maximizing A. I should maximize this, minimize, minimize, minimize for the first case. If I want to maximize A, why? Because they have negative sign. So you should minimize them to maximize A. If I want to minimize A, I should minimize this because it has plus sign. Maximize this because negative of this. If it is maximum, increase this because it has negative, it will be decreased. So A will be minimum. Increase, increase. So for each of them, I should find minimum or max. Now, let me tell you, for example, maximum and minimum of n over 4. For each of them, we know n over 4 because it is floor of that. We know it is less than or equal n over 4. It is an important rule for integer part. Floor, this sign is also floor. Or because this problem writes like this, I write here. So this one always is less than or equal x because you round it to down. The smaller number, greatest common number, greatest integer that is less than or equal x. So we have this. But for at most what? I want to say that what it is greater than equal what? So look, n over 4, for example, if you have 4 over 4, it is what? 1. If I have 5 over 4, then it is 1. It means what? The number here, 5 over 4 minus 1 over 4. If I have 6 over 4, it will be again 1, 6 over 4 minus 2 over 4. If I have 7 over 4, it will be 7 over 4 minus 1 over 3 over 4. And again, for 8 over 4, it will be equal to 8 over 4. So for this one, we will see that it is at least n over 4 minus 3 over 4. If you find the minimum, it is -1, it is equal itself n over 4, or 1 minus 1 over 4, minus 2 over 4, or minus 3 over 4. So the minimum part is minus 3 over 4. For any of them, we can write this like exactly this. N over 7 floor of that is less than or equal n over 7, and here n over 7 minus 6 over 7. Because, for example, like what number when n is 13? 13 over 7 is 13 over 7 minus 6 over 7. So if I write in one column, then I write for n over 14 and n over 28. For n over 14, it is less than or equal n over 14 greater than or equal n over 14 minus 13 over 14. And for GIF of or floor of n over 28, it is between these numbers. Now, easily by finding these 27 over 28, we can find minimum and maximum of A. Okay, so maximum of A is what? N over 4. Maybe we can't reach that, but we write, and then at the end we find some examples. So maximum of A is what? When you increase this, it will be, or let me, because maybe it's impossible to reach, I will write A is at most what? For n over 4, we write n over 4. Because you have negative, for each of them you write the minimum. Negative n over 7 minus 6 over 7 minus n over 14 minus 3 over 14 and minus n over 28 minus 1 over 27 over 28. It is for minimum, for maximum, and A is greater than equal what? So you minimize A, you minimize n over 4, it will be n over 4 minus 3 over 4, and then maximize n over 7. So you write minus n over 7 minus next one n over 14 minus n over 28. And like here that I calculate n over 4 minus this minus this minus this, if you use common denominator, it will be 0. So here we can say, okay, this one, all these things are 0, and also 0 because of this. So if I calculate this, I use common denominator 28, and here negative plus 6, 7, 28, 7 times 4, 6 times 4, 24, 14 times 2, 28, so this times 2, 3 times 2, 6, and plus 24, 27 times 1. So if I calculate this, it will be 30, 27, 57. If I calculate, let me see, yes. Oh, sorry, here I should write 13, okay, because we have 13 here. Okay, so here I should write 26, and instead of 30, I should write 26 plus 24, which is 40, 50. 50 plus 27 will be 77 over 28. And it will be around 2 point something. So because A is integer, A is at most 2. Now, let's find the minimum. We've canceled all of them, and it will be negative 3 over 4. And because A is greater than negative 3 over 4, and A is integer, A is greater than or equal 0, because if A is negative 1, it doesn't satisfy. Negative 1 is less than this. So by these two things, we understood that A can only be 0 between 0 and 2. So A is integer, A can only be 0, 1, and 2. For each of them, we find example. Okay, for n0, for example, if we consider n1, n is positive integer, A will be, all of them will be 0. So for 0, we found an example. Now, if you pay attention for 2, we found what we wanted to find. Let me tell you how you can find a good example. It was n minus 6 over 7 here. If you pay attention to this, and n over 4. So it seems by intuitive thinking that if n over 4 equals to floor of n over 4 is somehow like this, we want to reach 2, around 2. And n over 7 should be n minus 6 over 7. So from this one, we will see n should be 4q. For example, for this one, n should be 7k plus 6. So If we check, for example, the first one, 7, it's if 7, 6, if k6 is not multiple of 4, if k1, 13, 13 is not multiple of 4, if 7, 2, 14 plus 6, 20. It seems 20 is good. You can reach a great number. So let's check. And 20, I could tell you only 20 and find the answer, but I wanted to tell you how we can find great number, this strategy. Only the solution is not important. How we can reach the solution also is important. So A in this case will be 20 over 4 integer power 5 minus 20 over 7. It will be 2 minus this one, 1 minus 0. And it will be what? 5 minus 2, 3 minus 1, 2. 2 we've reached. For A1, if you consider 19 only, it will be decreased by 1. So A will be what? 19 over 4 minus 2 minus 1 minus 0, and it will be 1. So we've also reached 1. So how many possible cases do we have? 0, 1, 2, 3 cases. So the answer is C. Problem number 6, let n be a positive integer if the lowest common multiple of n and 12, okay, LCM of n and 12 equal to 60, and the highest common factor of n and 36 equal to 4. What's the value of n? Okay, so let's prime factorize. Here you can say LCM of, let me don't write n now. If you prime factorize 12, it will be 2 squared, 4 times 3. And 60 is 4, 2 squared times 3 times 5. And let me write also this one, HCF of, I don't write n now. 36 is 4 times 9 is 2 squared times 3 squared equal to 2 squared. So here, because in LCM we write all the primes that both numbers have, so here we have 2, 3, 5. So n can only have 2 to the x, 3 to the 5, 5 to the z. Maybe x, y, z, one of them or some of them are 0. So 3 to the y and 5 to the power of z. Also, I write this number. And I want to conclude about x, y, and z. So from the first one, let me write them here. Okay, from the first one, we know in LCM we select the greatest one. So because we have 2 here and 2 here, x here cannot be greater than 2. Because if x is, for example, 3, then in LCM you select 3. But because we select 2 and here is 2, x can be 2, 1, or 0. So x is less than or equal to, because if x is greater than 2, so here we don't have 2. We have x. For y, this and 1, we select 1. So again here, if y is greater than 1, for example 5, then here we should write 5, because in LCM we select maximum power. So here again, y is 1 or less than that, y is less than or equal to 1, and z, because it doesn't have 5 and here is 1, the maximum is 5 to the power of what? 0. So we select what here? We select 1, 1 is z, so z equal to 1. For this one, highest common factor, you select the minimum in highest common factor, in minimum power. So if x is less than 2, then it is not 2, it will be x. For example, if x is 1, then here it is 1. So x is not less than 2. X is greater than equal to, for y. Here it is 4. It is 3 to the power of 0. So the minimum is 0. So y will be 0 here. We understand because the minimum is 0 and it is 2, so it is 0. And for 5, it is 5 to the power of z. So it is 5 to the power of 1. We know that. And because we don't have 5, it doesn't have 5, so here we don't have 5. So from these two things, x greater than equal to, less than or equal to, so x equal to 2, y 0, z 1. The problem says what's the value of n? N is 2 to the power of x, which is 2 squared, times 3 to the power of y, which is 3 to the power of 0, times 5 to the power of z, which is here n. 5 to the power of 1, and it will be 4 times 5, which equal 20. Problem number 7. The digits 1, 2, 3, 4, 5, and 6 are arranged, form two positive integers with each digit appearing exactly once. How many ways can this be done if the sum of two integers is 570? Okay, so if we consider these two numbers, sum of them should be what? 570. So, because it says each digit appearing exactly once, so we have 1, 2, 3, 4, 5, 6. Here we know this plus this is 0 or 10. So the only possible case, 5, 5 is impossible, 6, 4 is okay, 3, 7 we need, 2, 8 we need, 1, 9 we need, or 0, 0 we don't have 0. So here, if I want to place one of them is 6 without loss of generality. For example, it is 6, it is 4, because it doesn't say A or B, the numbers don't have name. So one of them has 6 for one digit, one of them 4. So 6 plus 4, 10, we have 1. So this plus this equal to 6. Now what numbers are left? 1, 2, 3, 5. Sum of which of them equal to 6? Only 5 and 1. So here we can say, okay, if I consider the case as 6, 4, we have 5, 1, or I write 6, 4, 1, 5. So if we consider that 6, 4, 10, we have 1, it will be 7, and so we have two other digits. The digits that are left 2, 3. Also for this case, 6 plus 4, 10. We have 1. It is 7. And two other digits that are left are what? 2, 3. So you can place 2, 3 here or 3, 2. So two ways. And it is not important. 2, 3 here, 3, 2 here. Two ways. So two ways. And so you place 2, 3 and you can change them. 2, 3 here, you can change them and it will be 5. 2 ways plus 2 equal to 4. So we have 4 ways in all. Consider the following product of two mixed fractions. This equation we have, and where m and n are positive integers. What's the value of m plus n? Okay, so for solving this problem, I write it as a fraction. It will be 7m plus 6 over 7 times 3n plus 1 over 3 equal to 23. If I multiply both sides by 21, or 7 times 3, then I have 7m plus 6 times 3n plus 1 equal to 3 times 7 times 23. Now, I should consider different cases of these two numbers. So here, it is 3n plus 1. So 3 cannot be here. It is not multiple of 3, so you can't use 3 here. You can say it is 1 or 7 or 23 or 7 times 23. And we will see, because the remainder of this number when divided by 3 is 1. Remainder of 23 is 2 when divided by this. If you divide also the remainder here, 2 times 1, 2. Impossible these two cases. It says m and n are positive integers, so it is n is at least 1. So this one is at least 4, so 1 is impossible. So the only case is 7 for this one, because it is 7. So 3 times 23 is for this case, which is 69. Now, 7m plus 6 equal to 69. 3n plus 1 equal to 7 here. Now we can say 7m equal to 69 minus 6. If we subtract 6 from both sides, 63. And m equal to 9. And for this one, we subtract 1 from both sides. It will be 6. And n will be 2. So m plus n will be what? Equal to 11. So the answer is equal to 11. Problem number 9. What are the last 4 digits of the sum these things? Okay, so if we write them on top of each other, it will be 2222, 2022, and because we only should focus on the last 4 digits, it will be 0022, and until here 0022. It says we have 1, 0, 2 zeros to 10 zeros, so here we have 10 numbers. This one has 0, 0. And if we add up all these numbers, 10, 2 plus 1 to 11, 2, it will be 22. 11 twos we have. If you add all of them, we have 22, and you write 2 here. 11 2 you have here, 10 2, 1 2, 1 2, 12 twos. 12 times 2 is what? 24. So you write 4 here and 2 here. 2 plus 2, 4, and we have only 1 2 here, 2. So the last 4 digit equal to 24, 42. Okay, problem number 10. If A and B are distinct solutions to the equation this, what's the value of this? Okay, so we have a famous rule, ax squared plus bx plus c equals 0. Alpha plus beta, if are the roots, it will be negative b over a, and alpha beta equal to c over a. Now we want to use this formula to solve this problem. Okay, so a and b are roots of this equation, so a plus b equal negative b over a negative 10, and ab equal to c over a, it will be 20. Now here, we want a to the power 4 plus b to the power 4. At first we solve this. It will be a plus b squared minus 2ab. A plus b squared is negative 10 squared 100 minus 2ab, which is minus 40, equal to 60. And if we raise a, if I want to find a4 plus b4, I can say it is a squared plus b squared. We have a4 plus b4 plus 2a squared b squared. I subtract. Now it will be what? A squared plus b squared is 60. 60 squared minus 2ab squared is 20 squared. So it will be 36. This minus 2 times 400. 20 squared is 400. And it will be 3600 minus 800, which equal to 2800. For also 3 roots, you can use this Vieta's formulas. It is related to that. Problem number 11. The following diagram shows a star that is cut out from a square with sides of length 30. What's the area enclosed by this star? So it wants this area. Okay, so if I want to calculate this area, I say, okay, I consider the whole circle and subtract this one. And this is equal to this, equal to this. So I have 8 equal triangles, and I subtract. Why they are equal? Because the triangle, the star created by connecting each vertex to the midpoint of the opposite edges. So they are equal. If I consider it is A, it is A, it is A. We know A is 15. This one A, this one A, this one A, this one A. Now here I've connected this to this part. So this angle is alpha. Let me call, for example, A, B, C, D. And this is M, it is N. So you can say triangle BMC. This triangle is congruent to A and B. So congruent to triangle A and B. So if it is alpha, this angle is also alpha. We know it is 90, so when it is alpha, it is 90 minus alpha. So 90 minus alpha, alpha, so this angle is 90. Why these two triangles are congruent? Because two sides, A, 2A, and also A and B, 2AA, by two sides, an angle between 90. They are congruent, so alpha 90 minus alpha, it is 90. So this triangle, if we find the area of this triangle, it is y, for example, the area. We say area of a square is what? 30 squared minus. How many y do we have this? Y. Here, if I write all y's, then you have 1, 2, 3, 4, 5, 6, 7, 8, minus 8y. So the answer is equivalent to find y. For finding y, I want to find, I can find these two lengths, but because here I only want to find the area, so I can say this triangle is similar to this triangle, only I should check the ratios square. So triangle BMX is similar to triangle BMC. So here, the hypotenuse here is 15. Hypotenuse here is what? CM. So CM is what? CM by Pythagoras theorem is a squared plus here we have 2a plus 2a squared. And if you simplify, it will be a squared plus 4a squared. It will be 5a squared and it will be a root 5. So the ratio of these two triangles will be this one, a over a root 5. Now it's the ratio because we want to find the area. The ratios of their area is this squared, and it will be area of BMX over area of MBC. Area, so it will be a and a will be cancelled. This is squared 1 over 5. Area of BMX, we want to find it. Area of MBC is easy. You say a times 2a over 2. A times 2a over 2, it will be a squared. And a squared is what? 15 squared. So 1 over 5 equal to BMC over 15 squared. A 15 times 15. If we multiply both sides by 5, it will be 3. 3 times 15, 45. So area of BMC equal to 45. Now here we can say, okay, it is 330 squared. 900 minus 8 times y is what? BMC is 45. Area of 45, it will be 900 minus 360, which equals 0. 10 minus 6, 4. 8 minus 3, 5. So the answer is for solving the problems like these area ratios. There are around 50 important ideas in geometry from that are useful from qualifying level up to IMO. If you have any question about them, feel free to send message to my WhatsApp number in the description. Problem number 12. If x is a real number, how many solutions are there to the equation 3x plus 2 to the power of x plus 5 equal to 1? So what are the cases? Maybe the power is 0. 3x plus 2 to the power of 0, and it shouldn't be 0. It can be 1. We should check this case. Maybe 1 to the power of x plus 5. The base is 1. It's 1. And the other case is negative 1 to the power of even number, which equal to 1. So let's consider this case. X plus 5 power should be 0, so x should be equal to negative 5, and it will be 3, negative 15, negative 13 to the power of 0 equal to 1. So the first answer we've found. The next one, the base is 1. 3x plus 2 equal to 1. So 3x equal to, if you take 2 to right hand side, negative 2 plus 1, negative 1. So x equal to negative 1 over 3. So let's check this one. It will be 1 because 3x plus 2, 1 to the power of negative 1 over 3 plus 5. And if we calculate, it will be 5 power of 14 over 3, which equal 1. So the next answer. And the last one, the base should be negative 1 and power even. So 3x plus 2 equal to negative 1. So 3x equal to, if you take 2 to right hand side, negative 2, negative 3. So x equal to negative 1, and the power x plus 5 equal to negative 1 plus 5, 4. So it will be negative 1 to the power of 4, which equal to 1. So the last answer is, so we found 1, 2, 3 answers. So we found 3 answers, and the answer of this problem equal to. Problem number 13. The figure below each distinct letter represents a unique distinct digit such that the arithmetic holds this plus this equal to this. If W represents 5, so let me write W is 5. And what number does troop represent? Okay, so let's consider this case. Here, if we consider to second column from right, O plus T, O. So maybe we have carrier. If we don't have carrier, O plus T equal to O, or O plus T, for example, equal to 10 plus O, or other things. Or if we have carrier, we have at most 1, because 9, 9, they are different. 9, 8, 17, we have 1 at most. So O plus T plus 1 equal to O, or O, for example, plus T plus 1 equal to 10 plus O. And we can prove the others is impossible. So here, if you subtract O from both sides, then T is 10, and but T is digit contradiction. From this one, you conclude T is 0, but because T is first digit here, again contradiction for this one. If you consider O plus T plus 1, it will be OO, so T equal to -1, again contradiction. For this one, if we cancel O, so T equal to 9. For next part, for example, 20 plus O, T will be 19. But because T is a one-digit number, the only possible case for T is 9. So look here, I said if you don't have carrier, or if you have carrier 1 here. So the only possible case was this. So here T is 9 and we have carrier. So if I write T is 9, let me write, or I can write here 9, here 9, here 9. So, and T is 9. The first thing we've understood. Now here we say 9, 9. If also it has carrier, it is at most 1. It will be greater than 1, and we have carrier here, 1 here. So N is also 1. So this one is also 1. Now, because we have carrier here, 1, P plus S equal what? We have 1 here and 1 here, so it should be 11. Now, if we pay attention, here we have 1 here, 9, okay, P plus N S 11 if we want to consider different cases. Okay, so here because we have carrier here, so 1, 9, 10, and the carrier will be 1, cannot be 2. 1 plus 2O is S. Maybe it has carrier. So we understand S is odd from this column. S is odd because 2O plus 1 is odd. S equals 2O plus 1. 2O plus 1 maybe is S, or 10 plus S. In all cases, S should be odd. So here S odd. If you want to check the cases, S can be 1. No, because N is 1. It says unique distinct digit. S can be 3. S cannot be 5 because W is 5. S 7 can be. S9 not because T is 9. So in this case, P is 8. In this case, P is 4. So we need to only consider these two different cases. First, we consider the first case that P is 8 and S is 3. So it is 8. S is 3. This S is also 3. And okay, so we have these things. Okay, I write rest of that with green. So here, O and 1, if it is 3, O should be 1, but we have 1. So O plus 1 is 13. So 2O plus 1 is 13. So we conclude A equal to 6. O equal to 6. Now if I replace, we have 6 here, we have 6 here, we have 6 here, 6 here, 6 here, 6 plus 6, 12, 13, we have 1. 6 plus 1, 7. 7 plus what? We have 5. R should be 8. And it will be 15. Here, 1, 9, 9. 18 plus 1, 19. E is 9. But T was also 9. So we've reached contradiction for this case. Now we should check the second case. P is 4. S is 7. So here, case number 2. P4. S7. Okay, P4, S7, here S7. And okay, we have these things. Here, 2O plus 1 is 7 or 17. We should consider both cases. Okay, so if it is 7, 2O plus 1 here is 7. And in this case, we check 2O plus 1, 17. So if it is 7, so O is 3 from this case. From this case, O is 16 over 8. So O is 3, 3, it's okay. 3, 3, 7, and 3 here. 3 plus R is 5 or 15. Okay, it cannot be 15 because then R is 12, so R should be 2. 3 plus 2, 5. 9 plus 9, 18. E is 8. Okay, and we will see all the numbers are okay. T is 9 here, P is 4, S is 7, N is 1, and O is 3, R is 2, If I write this place, R is 2 and we've written W is 5, A is 8. Okay. Okay, and as you can see, all these digits are distinct. Let's also check this case to reach contradiction. This one it is 8, this one 8. 8 here, 8 here, 17. We have 1. 8 here, 8 plus 1, 9. 9 plus what? 5 here, so we should reach 15. So R will be 6 and 15 here, so you write 1 here, 9, 9. 18 plus 1, 9. And then we have contradiction because E is 9 here, and also we know T was 9. E equal T and contradiction. So the problem says troop is what? So T is what? 9, R is what? 20033, and P is what? 4. So the answer is problem number 14. In the following diagram, a white square here and 4 gray squares, these 4 of equal size, are drawn in a circle such that both dashed lines from diameters of the circle like this. If the diameter has length 60, so let's solve. Find the smallest possible value of the total area of the 5 squares. Okay, so I consider this A, this B, it is center. So it will be B, B, B. Here A, because the small squares are equal. Now, if you use Pythagoras theorem, this one will be what? Will be A over root 2. So the area is what? Is 4 times this times this. A over root 2 squared plus the area of the white circle plus 2b squared. So it will be 4 times a squared over 2 plus 4b squared. And if we simplify, it will be what? 2a squared plus 4b squared. We want to find the smallest possible case of this. And we know what the diameter is 60. Diameter is what? A plus B plus B plus A. Because diameter is 60, so radius is half of that, 30. So we can say A plus B, which equals to radius, equal to 30. Now here, I can say, okay, B equal to 30 minus A, and I replace here, suppose we consider it is F. F equal to 2A squared plus B is what? Here 4b squared. I replace b with 30 minus a, 30 minus a squared. Now I have what? 2a squared plus 4, 30 squared 900 plus a squared minus 60a. So it will be what? 2a squared plus 4a squared, 6a squared minus 240a plus 4 times 9, 36. So we can say if we factor from a squared minus 40. Sorry, here we have a. Yes, so let me just correct this part. Move it here. Okay. So this one plus this. Now, it will be 40a plus 600. Now, I want to find the minimum of, because I want to find minimum of whole, I should find minimum of this. And this function is a quadratic function. And we can write it as this one, a minus 20 squared. It will be a squared minus 40a plus 400. So you write plus 200 to reach this. Now the minimum is the case that this one equal to 0 because it is at least 0. So if a equal to 20, then we have minimum f, and it equal to 6 times 200, which equals 1200, and this minimum happens when a equal to 20, and because a plus b is 30, so b equal to 10. So the answer of this problem is 1200. Problem number 15. In the following diagram, ABC is a triangle, ABC, and D lies on AB, such that the ratio of ADDB is 3 over 4. So we can say it is what? 3x is 4x. Points E and G lie on AC and BC. E and G, okay, respective, such that DBGE is a parallelogram, DEGB, okay, or DBGE, and F is the intersection of DC and GE if the ratio of the area of triangle EDF to the area of ABC is M over N, where the highest common factor of M and N is 1. What's the value of M over N? Okay, so the area of triangle EDF over the area of triangle ABC. Okay, DEF, we call this one Y because it is parallel to this one. We can say this ratio equal to over this equal this over this. So we can say it is 3 over 4. You can say also it is 3t over 4t. And because it is parallel to this, so we can say it is 4 over 3. So it is this over this also is 4 over 3. We can say 4w, 3w. By similar triangles, you can say, or the name of the theorem is Thales' theorem. That if you have parallel lines, the ratios are equal. Now, the area here is y, and okay, this over this also equal this over this because it is parallel to this, so we can say, we can call this one, for example, 4, we have a 4, for example, E, 3E, okay. Now, it is y, we want to find this part, then this part, step by step. So let me write the rest of that with pink. This over this is, or this over this is 4 over 3. So this area, because it has common height, so you can say this over this is 4 over 3. So you should place 4 over 3 by, then this over this is 4 over 3. Now if you consider this one and this one, the ratio of area is the ratio of the bases. It's 4 over 3. So this over this part is 3 over 4. So y plus y 4 over 3y equal to what? 3, 3 plus 4, 7, 7y. So because this over this is 3 over 4. So we know that 3 over 4 times this, 3 over 4 times 7 over 3 y, which cancel, and it will be 7 over 4y. If you divide this over this will be 3 over 4. Now here, we know that this over this equal this over this. By similar triangles, you can say, or you can say this over this is this over this. The ratios are equal. Because we have parallel things here. This is 3 over 4, so it is also 3 over 4. So I can say it is 3D. This one is 4D. By similar triangles, you can prove. So it is 4 over 3. This over this is 4 over 3. So you can say 4 over 3 times this, which will be 16 over 9y. Now, here we want to calculate this part, the last part, in terms of y. I know, look, let me tell you something. You can calculate this part, or let me tell you, you can also calculate the whole part here. You can say what? You can say this is 4 over 3 times this. If you add all these things, we have what? 4 over 3 y plus 7 over 4y. So it will be, if you consider 12, 4, 4, 16 plus 12 plus 7 times 3, 21y. And if we simplify, it will be 28, 48, 49 over 12y. And then, because ABD over this is 4 over 3, you can say it is 4 over 3 times 49. Why the whole area? I want to say this one. Or 49 over 12y. And we can say what? We can say the answer is sum of them. So it will be what? 49 over 12y plus 4 over 3 times 49 over 12y. And if we add up and factor from y, here you can, okay, if we consider, because it is 1236, 3 times 49, 147. And here, 4 times 49, 36, 96. So it will be what? 13. 9 plus 4, 13 again. Plus 1, 14. We have 1. It's this. So the problem says what? It says divide this by this. So it will be what? The numerator is y, the denominator y, 343 over 36. And it will be 36 over 343. And the problem says find sum of them. So 36 plus 343 equal to 9, 7, and 3. So the answer of this problem is 379. So the only idea was finding the ratio with parallel lines and consider the bases. If you had any question, feel free to send a message to my WhatsApp number in the description and comments. Problem number 16. Eggs in a certain supermarket are sold only in trays containing exactly 10, 12, or 30 eggs per tray. It is thus impossible to buy exactly 14 eggs or any odd number of eggs. Yes, because you can't create 12, 14 or odd. However, it is possible to buy exactly 78 eggs using 78 using 4 trays of 12, 4 times 12, plus 1 tray of 30. It is 48 plus 30, 78, yes. What's the largest even number of eggs that is impossible to be bought from this supermarket? Okay, so look, I consider if I have A, if I subtract 12, I want to use 1/12 tray. At first, let me tell you. You can cancel 30 because you can create 30 by 3 tens. So we only focus on 10 and 12. So A minus 12, if A is multiple of 10, it's okay. A is even. The problem says find the maximum even number. If A is multiple of 10, it's okay. You can create by 10. If one's digit, okay, so let's consider one's digit can be, because A is even, can be 0, 2, 4, or 6, or 8. So if it is 2, then A minus 12 is multiple of this, multiple of 10, and it will be okay, because the ones digit will be 0. A minus 24, then you can, if you subtract 12 trays, if you can create, then if the ones digit is 4 here, it will be multiple of 10. For example, let me tell you, if, for example, you have 74, you can say, okay, 74 minus 24 is what? 50. And 50 is 5 times 10. Okay, so 74 is 2 trays of 14 eggs, 2 trays of 12 eggs, and 5 trays of 10 eggs. And you can create. So if the digit, one digit is 4 is okay, and then A minus 3 times 12, which is 36 for this one, and A minus 48. So if our A that is even, if A is greater than equal 48, so always you can create that. So we should focus to see what's the, so our answer is less than or equal 46. So we will check from 46. For 46, you can create it by, because we have 36, you say 3 times 12 plus 10. So you can create this. For 44, because negative 24, you say 2 times 12, 24 plus 2 times 10, you can create this. For 42, you can use this. You say, okay, 1 times 12 plus 3 times 10, you can create that. For 40, you can say, okay, it is 4 times 10, but 38. You can create that, because if you say 1 times 12, or you don't, if you don't use 12, so the rest is not multiple of 10. If you create 1 times 12, the rest is what? If you subtract, it will be 26. It's not multiple of 10. If you use 2 times 12, 24, then what is left? 14. 14 is not multiple of 10. If you subtract 3 times 12, 36, 2 is left. So you can create 38. So the answer is equal to 38. Problem number 17. How many integers and other in 1 to 2022 such that at least one of the digits of n is 2? Okay, so I consider from 0, the answer is not different because 0 doesn't contain 2. So 20, 22. Okay, so I divide it to two parts. I say, okay, 0, 1, 2, 1999, and the rest part from 2000 to 2022. Here, all of them, all the numbers have 2 because of this. So we have 23 numbers, this minus this plus 1. And now we want to calculate this. Here, we don't use direct way. As I said in my previous video, sometimes you consider all cases minus the bad cases. So you say 2000 numbers we have minus the number of cases that don't contain 2. So here we have 4 digits. Some numbers are have less than 4 digits. So the idea for solving this problem that you want to count 1 digit, 2 digit, 3 digit is that you also consider 0 here. Then for example, if you consider 0001, it is number 1. So here it can be 1, 0, 1, 3, 4 to 9 because we want to calculate the number of cases that don't contain 2, the bad cases. 0. Here because we calculate from 0 to 1999, we calculate. So here we have 2 cases, 9 cases because we don't have 2, 10 minus 1, 9. 9 cases, 9 cases. So these are all the numbers that don't contain 2. We subtract from 2000, which is from 0 to 1999. So we calculate the numbers here that contain 2. So it will be 2000 minus 2 times 9 cubed, which is 729. And if we calculate 2 times 9, 18. 2 to 4 plus 1, 5. 2, 7, 14. Okay, if we subtract 10 minus 8, 2, 9 minus 5, 4, 9 minus 4, 5, and 1 minus 1, 0, and then we add 23 here. So 3 plus 2, 5, 2 plus 4, 6, 5. So the answer of this problem equal to 565. Problem number 18. What's the smallest k such that every subset of 1 to 99 with exactly k integers contains at least 2 distinct integers x and y such that absolute value of x minus y is less than or equal to. For solving this, we use one of the most useful ideas, pigeonhole principle. So we consider 1, 2, 3 and grouping. This idea also is useful in round 2, 4, 5, 6, 7, 8, 9. And the last group is 97, 98, 99. Now, the first group is here, second, third group, and look, 9 over 3, 99 over 3, 33. So 33rd group is this. Now, if k is greater than equal 34, then because we have 33 groups, then from one group we select at least 2 members. So if you select 2 members from a group, then the difference is at most 2. So it is okay. So now you guess the answer will be greater than equal 34 or less than or equal. Because the answer says find the minimum, we say 34 works. So the answer is 34 or less than that. So less than or equal 34. Now I will find an example with 33 that doesn't satisfy this. So you find an example with 33 or less doesn't works. So the answer is what? Multiples of 3. 3, 6, 9. If you consider all of them, you have 33 elements. And if you consider any 2 of them, their difference equal at least 3. So 33 doesn't work. So the answer is strictly greater than 33. So the answer is greater than equal 34. So the answer is this, 34. So the idea I showed you how to prove something minimum and maximum is also so much useful for round 2 problems. There are some important ideas that are common in round 1 and round 2. One of them is this. Okay, problem number 19. I saw this problem before the exam. It is famous problem. In the following diagram, ACD is a triangle. And so it's good to solve important famous problems, no famous ideas. If you know famous ideas, then it helps you in many problems. Okay, ACD is triangle AB equals BC, ABD equal 45, and BDC, okay, ABD 45, BDC equal 15, ADB is X. What's the value of X? So for this problem, the idea is you have 15 here, and we try to create 15. Okay, now here we create 15. Because it is 15, it is 15. These two things are equal, but before that, it's 15, 15, so it is 30. And because it is exterior angle, this plus this, sum of two non-adjacent. And it is 45, it is sum of two non-adjacent, so it is 15. So what plus 15 is 45? 30. So this angle is 30. Because 30, 30 isosceles triangle. So this one, we know this one equal to this one. From the assumption here, the problem says AB equal BC. So BC, let me call this one, for example, E. BEC is an isosceles triangle, so B equal to BC. Now here, it is 15, 15, so also it is equal to this. Now, if I draw this one, okay, what can we say? We say, okay, it is isosceles triangle. It is 15 plus 45, 60. So because it is isosceles triangle, it is 60, 60, and we understand, okay, it is equilateral triangle because all angles are 60. So these two angles are equal. Now, 60 plus 30, 90. So it is also 90. So 90 isosceles right angle, isosceles triangle. So it will be 45. So 45 equal to x plus 15. So x equal to, if you subtract 15 from both sides, will be 30. So x equal to 30 degree. Problem number 20. What's the area of a triangle with side length these three terms? Okay, so one way is to use Heron's theorem, but because we have root and it is similar to Pythagoras theorem, we can use an easier way. Okay, in this square, let's say rectangle, because it's 12, 14, 6, 7, we create this. If I call this one A, this one will be A. If I call this one B, 12 squared, 7 squared, it will be B, and this one C, it will be C. 7 plus 7, 14, midpoint here, midpoint here. And now we want to find area of these triangles. So we can say area of the whole rectangle. Answer is what? 14, 7 plus 7, 14, times 6 plus 6, 12, minus 7 times 6 over 2. This one, we've subtracted this one 6 times, minus 6 times 14 over 2. We've subtracted this one, minus 7 times 12 over 2. We've subtracted this one, so it will be what? 14 times 12. You can say 14 is 2 times 7, and 7 times is 84. So it will be 2 times 4, 8, and 160. And then we simplify, it's 3 minus 21. We subtract this, minus 42 minus this 6 minus 42 again. So if we answer, it will be 84, and this minus this will be 84 minus 21, and it will be 3. So the area of this triangle and the answer of this problem equal to 63. Problem number 21. If x equals third root of 4 plus the cube root of 4 plus cube root of 2 plus 1, what's the value of this term? Okay, so if I consider this one a, then x is a squared plus a plus 1. We know if we multiply a minus 1 by a squared plus a plus 1, then we have a cubed minus 1. And a cubed is what? 2. 2 minus 1 is 1. So we understand if we divide both sides by a minus 1, then we conclude it will be 1 over a minus 1. It is this. Now, let's focus on this part. It says calculate. So here I say, okay, it is 2022 plus, if I use common denominator x cubed, it will be 3x squared plus 3x plus 1. And here we can add what? If we add plus x cubed, then x cubed over x cubed is plus 1, then I subtract 1 so that it will be true. So now we can use identity. We can say it's 2022 minus 1 is 2021. The numerator is x plus 1 cubed over x cubed. So it equals 2021 plus x plus 1 over x cubed. Now we know x is what? X is 1 over a minus 1. X plus 1 is what? Is 1 over a minus 1 plus 1. So if we use common denominator, it will be a minus 1, 1 plus a minus 1, 1 and negative 1 will be cancelled, and it will be a over a minus 1. And now, x plus 1 over x will be what? X plus 1 over x will be a over a minus 1 over 1 over a minus 1. We can cancel these two things and it will be a. So it will be 2021 plus a cubed. A was what? A was what? Cube root of 2. So a cubed is 2. So it will be 2021 plus 2, which equal to 2023. Changing variable is one of the most useful ways. And in previous years we've solved, and also for other problems we should use that. Something like changing variables, some ideas are useful in all years. If you want to know the important ideas, as I said before, feel free to send message to my WhatsApp number in the description and comments. Problem number 22. If we have this fraction equal to this fraction for some integers a, b, c, what's the value of a plus b plus c? For this problem, we cross multiply. So 2 root 15 plus 2 root 35 plus 2 root 21 plus 2 times 5, 10 equal to, if we cross multiply, at first we multiply root 3 to all of them, it will be a root 21 plus root 3 times this, b root 15 plus c root 3 will be 3c. The next one plus 2 root 5, it will be 2a root 5 times 7, 35 plus 2 root 5, it will be 2b, 5, it will be 10b. 2 root 5, it will be 2c root 15. And 7, it will be plus 7a plus b root 35 plus root 7 plus c root 21. Now, because a and b and c, a, b and c are not irrational, so they are rational and also more specific integers. So corresponding coefficients should be equal. Now, we have three things. Root 15. Root 15 equal left side to the coefficient, right side. b plus 2c. Now, next one. Root 35 equal to 2 here. 2a plus b. Now, root 21 here. It equal to 2. 21 here, a and c plus c. And the last one, constant term. 10 equal to 3c, because a, b, c are integers, 3c plus 10b plus 7a. Okay, now we have these four equations. If we consider these two equations, if you subtract, for example, this minus this, left side will be 0, right side b and b will be cancelled. It will be 2c minus 2a. If we divide both sides by 2, c minus a, so c equal to a. And because a plus c is 2 and they are equal, so they should be 1. And if you replace 1 here, a, replace a with 1, 2, and 2 here, so b will be 0. Because if you take 2 to the left hand side, 2 minus 2 is 0, so b will be 0. So this equation, you can check it will be correct. And because b is 0 plus 2, 2, this one b 0 plus 2, 2, 1 plus 1, 2, it will be okay. And this one, 3c, will be 3 plus 10b, 0 plus 7a, 7, 3 plus 7, 10. So we have these things, and a plus b plus c will be what? Will be 1, a, b 0 plus c 1 equal to 2. Okay, problem number 23. How many integers n are there in 1 to 2022 such that floor of cube root of n is a factor of n? So for solving, because we don't know the idea is what, so we check some numbers. For n1, then cube root of 1 is a factor of 1. It's okay. For n2, cube root of 2 is between 1 and 2, because look, cube root of 1 is 1. The next one, it increases until cube root of 8 is 2. So all numbers between 1 and 2, it's 1 point something cube root of them. So it is okay. So until n7, you can say all the numbers are okay, because cube root of 7 also is 1. But when you say n8, then cube root of 8 is 2. So the number should be even. So for example, for n9, it is bad because cube root of 9 is 2 and it's bad. So even numbers are good. So until what number? The next one is cube root of 27 is 3. So until 26. And 26 is okay. So even numbers here. Multiples of 2 in this interval, which is 26 minus 8 over 2, plus 1 here, all numbers 1 to 7, 7. 26 minus 8, 18 over 2, 9 plus 1, 10. Now, the next one, you say what? 9 plus 1, 10. You say n equals 27, it is 3 until n 63, because after n 64, cube root of that will be 4. So cube root of all of them, for example, like 27, the floor of that is 3. So here we should calculate multiples of 3. And it will be 63 minus 27 over 3 plus 1. 63 minus 27, 13, 6, 5 minus 2, 36 over 3, 12 plus 1, 13. So as you can see, the first number is 7, the next number is 10, the next number 13. So it is an arithmetic sequence. So it will be 5 plus 10 here plus 13. Now, we should check until what number we should calculate. So n10 to the power of 3 is 1000. If you consider n11 cubed, it will be 13, 31. We should calculate until what number? Until 20, 22 here. Okay, so the next number, if you calculate 12 cubed, it will be what? 1728. So we can check the next number. If we calculate 13 cubed, it will be 2197. So enough. Until here, between these numbers, 1331 to 1727, their cube roots are what? 1331 is 11, all of them, the floor of them. So we should calculate multiples of what? Multiples of 11. And we can say, okay, 1727 minus 1331 over 11 plus 1. And if we calculate 7 minus 1, 6, 12 minus 3, 9, 6 minus 3, 3, 1 minus 1, 0. If we divide it by 11, it will be 336, and it will be 3366 6 plus 1, 37. So the last one is 37, and that satisfies this condition. Now, from this one to this one, 12 cubed is 1728 until we can't have these numbers. So we should see what's the nearest number to 2022, and we should calculate what multiples of 12 here. So if you check, you can see 2020 remainder when divided by 12, then the remainder will be 6. So if you consider until 2016, it will be good. So it will be 2016 minus 1728 all over 12 plus 1. And if you calculate that, it will be what? 16 over minus 8, 8, then 0, 10 minus 2, 8, then 9 minus 7, 2, and 1 minus 1, 0 over 12 plus 1, 2 times 12, 24, 48, 4 plus 1, 25. Now here 25 Now we should calculate this number. Here we can say it is an arithmetic sequence, the first one plus last one over 2 times the numbers. So you say numbers 37 minus 7 over 3 plus 1 and plus 25. 37 minus 7 is 30. 7 plus 37 is what? 44. 44 over 2 is 22. 10 plus 1 is 11 plus 25. Okay, if we calculate 22 times 11, 2222, it will be 242 plus 25, and it will be 7. 2 plus 4, 6, 2, 6, 7. Problem number 24. Before the exam, I released a video. I think the day before the exam, I released a video. In that video, I told some useful ideas. Exactly, you can use that here. You also, it has some basic solutions, but because this idea is useful in many problems of SMO, also the student that participate junior is good to learn how to use differentiation for simple things. So for example, if I consider this f of xy, then I differentiate from f. I think it takes around 30 minutes to learn differentiation that you need for junior parts, and I can say all years you need that in senior open sections. In open section, I told some professional level of differentiation, Lagrange multipliers. So if you differentiate, and the solution will be so much easy. 4x plus 4y plus 4 equal to 0. And if you differentiate from y, it will be 4x. Here it is 0, 4x plus 10y plus 10 equal to 0. If we divide by 2, or let's just subtract this minus this, then we have 6y plus 6 equal to 0. And if we divide by 6, y plus 1 equal to 0, then y equal to negative 1. If we replace y with negative 1, negative 4 plus 4 is 0, so x will be 0. And if we replace this in the f, it will be what? 2 times 0, 0. 0 to this one, 0. Y negative 1, it will be 5. Y negative 1, it will be negative 10. 13. 13 minus 10, 3. 3 plus 5, 8. Okay, we've solved this problem with the idea I told you before the exam, exactly the day before the exam. It has also, you can change it to some perfect square. You can solve also with that way. If you want to solve it that way, or any other question, you can send message to my WhatsApp number in the description and comments. But because this idea is so much general, I solve this problem again with this idea. Problem number 25. The following diagram shows a rectangle that is partitioned into 17 squares. All of them are squares. If the two smallest squares, shaded in gray, have side of length 2, so I place two 2's here, what's the area of the rectangle? Okay, I consider, suppose the side of this square is A, then we can say what? It is A, so it is A, it is 2. So for this one, it is A plus 2. Now here, this is this one. The whole one is A, this one is 2. So this one will be what? A minus 2. This is A minus 2, it is A. So this length will be A minus 2 plus A, 2A minus 2. Now here, for this one, A minus 2, it is, this length is A minus 2 because of this 2A minus 2. If you add these two things, it will be 3A minus 4. Okay, now here is 3A minus 4. We have 2 here, so it will be 3A minus 6. And here it is 2, it is A plus 2, so it will be A plus 4. Okay, now here we can say, okay, this length from this part is 3A minus 6. From this part is A plus 2 plus 2 plus 2. So A plus 2 plus 2 plus 2 equal to 3A minus 6. So if we subtract A, it is what? 6. If we subtract A from both sides, it will be 2A. If we take negative 6 to right hand side, it will be positive 6 plus 6, 12. So A will be 6. Now I write the areas of each of them, it will be 10. 6 minus 2, it will be 4. 2, 6, 12 minus 2, 10. 3, 6, 18 minus 4, 14. 3, 8, 16 minus, 3, 8, 18 minus 4, 14. 18 minus 6, which will be 12. 6 plus 2, 8. And the last one, this one also is 6. Okay, so let's see what other things we can calculate. This is 12, so it is 12. 12 plus 2 is 14. And here it is 8. So this one is 6 because it is 2. 6 plus 10, 16. Here it is 14 plus 10, 24. Okay, now if you want to calculate others, we don't find any good terms, so you let me write the rest of that with green. We consider this one B. Okay, this side is from here 16 plus 10, 26. From here B plus what is 26? 26 minus B. Okay, now here we want to find this length. What plus B is 26 minus B. So the whole term is 26 minus B. If you subtract B, it will be 26 minus 2B. Now here, if I want to find this, the whole term is 26 minus B minus 2B. Because of this minus B, here it will be 26 minus 3B. And now, if you want to find this length for this square, 26 minus 2B plus 26 minus 3B, which will be 52 minus 5B. Okay, now here, from this part until this part, from top, we can say 52 plus 52 minus 5B, this part plus 26 minus 3B, equal to this plus this, and we have them 24 plus 10 plus 4, and it equal to what? 34, 38, and we can say what? Here, negative 5B, negative 3B, negative 8B, 52 plus 26 will be 78, equal to 38. If you take 8b to right side, 78 minus 38 equal to 40b equal to 5. Okay, let me write rest of that with red. Okay, now we want to find this length to find the area of the rectangle. 52 minus 5b, it is what? 5b, 25. It will be 27, this part, and we can also use this 14 plus 12, 26, 36, 40, 40 plus 24, 64 times this one. 26 minus 5 is 21, 21 plus 10, 31, 37, 47, 51. And if you calculate this term, it will be 32, 64.